right, so this is lesson 93, using fraction bars as a symbol of inclusion. When you have a complex fraction like this, where you have different operations happening in the numerator and different operations happening in the denominator, it's as if this has brackets around it, and it says, do me first. So you're going to have to do everything in the numerator and everything in the denominator before you divide, if you're able to divide. All right, so in this, sometimes one thing that helps is to just essentially read it and to really think about what needs to happen first. So we have to remember our order of operations, which is PEMDAS, so parentheses, exponents, multiplication and division. Remember, we do those in order from left to right. If division comes first, we do that first. If multiplication comes first, we do that first. And then addition and subtraction. So in this equation, we have parentheses here and we have parentheses there. So let's take care of those first and rewrite everything else that's here. So we have 4 minus, and then we have 3 minus 7. You could think of that as 3 plus -7. So the signs are opposite, so we're going to subtract. 7 minus 3 is 4. The 7 is negative, the larger number is negative, so it's a -4. So 4 minus -4, okay, don't lose the fact that there's 2 negatives there, plus 3 times 2 plus 6. Divided by 2 times -4 minus 1 is the same thing as -4 plus -1, okay, which gives us -5. The signs are the same, so we add. They're both negative, so the answer is negative. Okay, so now we can move on. We're going to fix this double negative because a double negative is a positive, right? So now those 4s are being added, but we're not going to add them yet because we have to do our multiplication first. So we'll just rewrite it as 4 plus 4 plus 3 times 2 is 6 plus 6. And in the denominator we have 2 times -5. I could have multiplied there. I don't know why I didn't. That's 2 times -5. A positive times a negative yields a negative. So that's going to be -10. And now we can just simplify our numerator. 4 plus 4. Well, actually, what I'm seeing here, I see a 10 there, and I see a 10 there. So 10 plus 10 is 20. 20 over -10. We have a positive being divided by a negative, so our answer is a -2. All right, so this is the very last problem on your note sheet. So we did the first one, and now we're going to do the last one. And you guys are expected to do ones in between because that's where real learning happens, is you apply what you've learned. And I'm going to figure out a way to post the correct answers so that you can make sure that you've done it correctly. Actually, you don't need that. You can go into your book. These examples will either be examples in the book or they will be practice problems, which are, the answers are in your solutions manual. So do the work and then check your answers to make sure you've done it correctly. So here we are at the very last problem. So we have a couple of things in parentheses on the top, so we're going to do those first and rewrite everything around it. So we're going to start by writing 2. And it's being multiplied by 23 minus 19, which is 4, plus 2 plus 6, which is 8, times 3. And I just put that 3 in parentheses to show I am multiplying those two. You could have put a raised dot in between, that's fine too. And now the denominator divided by 5 minus 7. So 5 is positive and 7 is negative. Remember that negative sign is attached to the 7. Since the signs are different, we subtract, and 7 is larger and it's negative, so we have a -2. So 5 minus 7 is negative 2, plus 6. Once again, signs are different, so we subtract. The larger number's positive, so it ends up being a positive 4. Now we can do the multiplication on top. 8 plus 24 divided by 4. Okay? And we know that 3/8 is 24, so 4/8 would be 32. 32 divided by 4 equals 8. Lesson 94 is just identifying what terms are and learning how to add like terms. I believe we've already done some of this, but so this will be a little bit of review. So terms are separated by addition and subtraction signs. A term that does not contain a variable is called a constant term. Okay, so then I gave you this example and I asked you to write, how could you write this example? Whoops, above. We have 5 being repeatedly added. Repeated addition is the same thing as multiplication. So we could change that 5 plus 5 plus 5 to 4 times 5 plus 4 times 1 plus 3 times 5 plus 2 times 1. And then if we substituted x and y for the 5 and the 1, we would end up with this equation. 4 times x plus 4 times y plus 3 times x plus 2 times y. Okay, and then once it's in this form, we can add our x's and we can add our y's. And when we do that, we simply add the coefficient on the x. Here it's a 4, there it's a 3, and the coefficients on the y. Here it's a 4, there it's a 2. So if we added like terms, we would have 7x plus 6y. Okay, so this is just an example of why we can add like terms. We can add them because these 5s could all be added to those 5s, right? In the end, we would have a total of 7 5s and a total of 6 1s. Okay, 7x plus 6y. In this first example, it's the first example in your notes, we look and we can see that we've got a negative 3x. I'm just going to box it. Feel free to box, to use maybe even colored pencils or something so that you can find your like terms. So I'm looking for another x term, and I see I have 2x. Okay, look at how I boxed the sign with the coefficient and the variable. The coefficient is just the number attached to that variable, the number being multiplied by the variable. All right, and then the sign is very important to keep that with the coefficient. In this equation, we have 2 constants. Okay, remember we just defined what a constant was. Okay, it does not have a variable attached to it. So these constants can be added, these x terms can be added, and I don't have anything to add to the y term. We have a negative 3x and a positive 2, opposite signs, so we have to subtract. The larger number is negative, so it's going to be a negative number. So negative 3 plus 2 is negative 1x. Do we need that 1 there? Not really, but I'm putting it there just so that people understand that I do have 1x left and negative 1x. I can't combine 2y with anything, so I just write that down. And then I'm going to combine my constants. 3 plus 7 is 10. Okay? This is an expression. It's not an equation. I called it an equation earlier, but it's really an expression because there's no equals mark. We don't have it set equal to anything. But this expression equals this, and that's your final answer for that one. Let's do another let's do the one beside that one, top right. 3x plus 2m minus 14x. All right. Plus 4 minus 2. Okay, sometimes what it does, what helps, see how, like on the previous example, I put squares around my x's and I circled my constants. So just to differentiate the like terms, sometimes that can be helpful. So I'm going to look for all my x terms. Okay, I have 3x. I have negative 14x because I'm going to remember that that negative sign goes with the 14x. I have a positive 2x. And that's it. Okay. I have a positive 2m. I'm going to do a square around my positive 2m. And I have a negative 4m. And then I have these two constants, positive 4, negative 2. I'm just going to underline them. Okay. So now I'm going to write in orange. Let's combine our x terms. Well, we have 3 plus negative 14. That's subtraction. Our answer will be negative 11. And then plus 2 will be negative 9. X. And then we have a positive 2 and a negative 4m. Opposite signs, so we have to subtract. The larger one's negative, so it's going to be a negative 2m. Positive 4 plus negative 2 is positive 2. And that right there is our final answer for this expression. Lessons 95 and 96 are closely related. So what we're going to do is we're going to have some practice with variables on both sides of the equals mark. I'm going to go through all of these practice problems because sometimes this concept can be a challenge to students. But if you have been diligently practicing adding things to both sides, then you should be doing fine. The both sides thing really comes into play with this concept, okay? So we had just learned that we need to combine like terms, or maybe that was more of a review. So I have a 3x over here, but I have an x over there. So how do I combine those like terms if there's an equal sign in between? Well, I can't just add them together. Okay, I have to subtract it from this side and this side. And that way I combine my like terms. So I'm going to subtract an x here and subtract an x there. Okay, when I do that, I have 3x minus x equals 2x. I'm going to write my plus 3 equals, when I have this, right, my x's go away. X minus x is 0. So I just have my negative 5. Okay? Now I need to bring my 3 over because it's a constant, just like my 5's a constant. So I'm going to bring it over by doing the opposite of what's happening. Addition's happening, so now I need to subtract. Minus 3 minus 3. Okay, or plus a negative 3 plus a negative 3. It's the same thing. Right here, that goes to 0, and I'm left with 2x on the left equals negative 5 plus negative 3 is negative 8. Okay, I can figure out what x is now by dividing both sides by 2. So I find that my x equals negative 8 divided by 2 is negative 4. Okay, so when if I wanted to check this, I would just put a negative 4 in for x. And my check would look like this. Negative 12, because negative 4 times 3 is negative 12, plus 3 equals negative 4, put that in for x, minus 5. Okay, and if I do the math, negative 9 equals negative 9, so it does check. All right, this one's a little bit simpler. We just have one constant and we have two x terms. So what we have to recognize here is that this is a negative. So in order to do the opposite, we have to add x to both sides. All right, so on the left we have 5x minus 2 equals, well, negative x plus x is 0. Okay, but now we've got to get that 2 over to the other side of the equation so that we can figure out what x is. So we have to do the opposite, which means add 2 to both sides. So we end up with 5x on the left equals 2 on the right. Okay, and now we divide both sides by the coefficient of the x. So divide by 5, divide by 5, and we find that x equals 2 over 5. Once again, if we substituted the 2 over 5 for x, we would find that our equation works out. All right, so here we have a negative 4x, and on the other side of the equal sign, a positive 7x. I always like to bring my x's to the left. I think it's always good to start off that way when you're just learning these concepts. As you do algebra for longer, you'll be able to move it to either side and it won't matter. But right now, I'm just going to move the x's to the left, move the constants to the right. This time, I feel like starting with a constant, and that's fine. So my constant is positive 3, so I have to add the opposite, which is a negative 3, to both sides. All right, so I end up on the left side with just a negative 4x equals 7x minus, you have 2 negatives, so you add, and you get a negative 11. My camera girl told me I forgot the x, so she was good. All right, so now I need to get my x's together, so I'm gonna subtract this 7x, doing the opposite. Here it's positive. In order to get it over, I have to do the opposite, so this will go to 0. Minus 7x. So 7 plus 4 is 11, and it's negative because they're both negative. So negative 11x equals negative 11. To get x by itself, I divide both sides by negative 11. And x equals, a negative divided by a negative is a positive, and anything divided by itself is 1. Lesson 96, and so the only difference really between this lesson and the lesson 95 that we just went over is that this is basically a combination of lessons 94 and 95. So in lesson 94, we combined like terms. In lesson 95, we simplified so that we could figure out what x was. In lesson 96, we're going to do both of those things. So I've already taken the liberty of circling my variables and underlining my constants, okay? So first thing I want to do is combine my like terms that are over here. So I have a positive 4, a positive 3, and a negative 2x. All right, so 4 plus 3 is 7. 7 minus 2 is 5. So I end up with 5x plus 2 equals 12. I'm not going to do anything with my constants in that first step, but now I am. Okay, now I'm going to get rid of my constant by subtracting it from both sides. Key term, both sides. And I end up with 5x equals 10. Okay, now I can divide both sides by 5. And I get that x equals 2. When I substitute 2 in for x, then I will come up with 12. So 2 times 4 is 8, plus 2, plus 2 times 3 is, all right? So 16, 8 plus 2 is 10, plus 6 is 16. 16 minus 4 equals 12, so we're set. We're good. Next one. Once again, I've already done all the circling. I have a 4x plus a 3x minus an x. I'm not going to worry about this side yet. I went ahead and circled it just so we would keep in mind that it's over there. So 4 plus 3 is 7 minus 1 because this x has an invisible 1 that's actually there. So we end up with 6x plus 5 equals negative 7x minus 8. Now it's just like 1 from the previous lesson. We have to get all of our x's over here and all of our constants over there. So we're going to add 7x to both sides. I'm going to go ahead and show getting rid of my constant in the same step, and I'm okay if you do that as well. Minus 5 from both sides. So when I add my x's, I get 13x. Okay, 5 minus 5 is 0, so nothing there. Equals, this goes to 0 because it's a negative 7x plus a positive 7x. So 13x equals negative 13. Negative 8 plus negative 5 is negative 13. If I divide both sides by 13, I find that x equals negative 1. Negative 13 divided by 13 is negative 1. And once again, you can check that by substitution. Equation, we have 3x minus x minus 4x. So this together is negative 5, positive 3 gives us negative 2x minus 3 equals, these x's I can combine because they're on the same side of the equals mark. So 5 and negative 2 is 3x plus 12. Okay, so now I'm going to do the next step. Subtract 3x from both sides. I'm going to add my constant to both sides too. Plus 3 plus 3. So now all my x's are going to be on the left and all my constants on the right. So negative 2x plus negative 3x is negative 5x. And that equals 12 plus 3, which is 15. Because those cancel and those cancel. So now if I divide both sides by negative 5, I get that x equals positive 15 divided by negative 5 is a negative 3.